Dear students, welcome to EPG Pathshala. Today in this module, we will be discussing about incineration and combustion. Any solid material that is of no use or it is unwanted, they are discarded into the environment. They are generated from various sources due to human activities. The sources can be a domestic source, residential source, industrial source, agricultural, institutional, industrial, biomedical and e-waste. Now these wastes are increasing day by day. The population explosion or the population growth associated with industrialization and urbanization has resulted in a generation of huge amount of waste which is just being discarded into the outside environment. We should do something for managing this waste. As you all know, waste management includes a number of steps, starting from waste collection to segregation to treatment and processing, and finally it is disposed. The waste from different houses are collected and they are brought to a common place called as a transfer station where they are segregated. The segregation can be done either manually or mechanically using various equipments. Then they are processed and treated. Now treatment can be done by a thermal route or a biological conversion route. Thermal route involves the use of high temperature where the waste is combusted and then converted into ash and other gaseous products. The biological conversion routes includes composting, vermicomposting and biogasification. Now today in this module we will be discussing about a thermal decomposition route where the waste after segregation is subjected to a very high temperature of around 900 to 1100 degrees Celsius and it is combusted in the presence of oxygen. Now this process is termed as incineration, and at the end of incineration the volume of waste is reduced by 90% by volume and 75% by weight. And the end product, that is ash which is left out after incineration, is safe for containment in a landfill. So the learning objectives of this module include: first, to understand the concept of combustion, then to understand the process of incineration, to study the various incineration technologies, and finally we'll end up by studying the various advantages and disadvantages and applicability of incineration. Finally, we will also estimate the energy generation potential of various wastes. Now, as I told you earlier, waste is an unwanted material that is of no use to the owner and hence is disposed of in an open area. Disposal into the land or water body is just not a solution, but they create a huge problem to the environment, thereby ending up in a lot of environmental and health hazards. The polluter pay principle, which is proposed in the Kyoto Protocol, it is for the environmental protection, and this acts as a force for the industries to treat the waste prior to disposal. Thermal treatment is one option which uses a very high temperature to degrade or destruct the waste. They are designed to thermally degrade the waste and recover energy in the form of heat or electricity. Its main purpose is to reduce the impact of the municipal solid waste on the environment. So as I told you earlier, incineration is a type of combustion where the waste is oxidized in the presence of oxygen and high temperature of around 900 to 1200 degrees Celsius, resulting in the production of carbon dioxide and water and a residue called ash. Though incineration process reduces 90% of waste by volume, it generates a huge amount of gaseous and particulate pollutants. Now let's look into the combustion and then we will study about incineration. Now what is combustion? Combustion is a process by which the material is burnt in the presence of oxygen. It is an exothermic reaction between the substance being burnt and oxygen. Combustion breaks down the organic and inorganic substances into a stable end product, carbon dioxide and water. The reactions occur between carbon and hydrogen and oxygen present in air to form carbon dioxide and water. In addition to carbon dioxide and water, the oxides of sulfur and oxides of nitrogen are also released during this process. Can affect the combustion process and they might result in the release of carbon monoxide, which is a very dangerous gas. As you all know, the carbon monoxide is a very dangerous gas which combines with the hemoglobin of your blood and it reduces the oxygen carrying capacity of blood, which can be fatal. Carbon monoxide is harmful and hence to avoid its formation, you have to flush in sufficient amount of oxygen into the chamber. All combustion furnaces should be provided with good mixing facilities to provide uniform distribution of air throughout the waste material and other gases released during the burning of waste. At the end of combustion process, an incombustible particulate matter called as bottom ash is left in the combustion chamber or the incinerator. The particulate matter, some amount of particulate matter are also emitted through the chimneys and this is termed as fly ash. So the particulate matter which is emitted outside the chamber along with the flue gas, they are termed as fly ash. Now incineration process is one of the best example of combustion. So as I told you earlier, incineration is a combustion process and where the waste is burnt in the presence of oxygen at a very high temperature of about 900 to 1100 degrees Celsius. This temperature is selected, one, to ensure a good combustion, second, to eliminate the odor problems, and third, to protect the walls of the incinerator. Incineration is termed as a thermal treatment and is considered as a best alternative route for disposal of solid waste. During the process of incineration, the waste material is oxidized to produce ash, flue gas and heat along with water vapor, nitrogen, carbon dioxide and oxygen. In addition to carbon dioxide, other gases like the carbon monoxide, hydrogen chloride, hydrogen fluoride, nitrogen oxides, oxides of sulfur, volatile organic carbon, dioxins, furans, PCBs are also produced depending upon the nature of waste and the availability of oxygen. At the end of incineration, bottom ash remains as the inorganic constituent of combustion. The solid lumps of particulate matter are also carried by flue gas and it is let out, which is called as fly ash. This in general, to avoid the emission of these particulate matter, that is the fly ash emissions, it is essential for particular user to install a air pollution control device such as an electrostatic precipitator to remove these particulate matter so that these particulate matter will not be emitted or released outside into the environment. So, to avoid or reduce the air pollution problem, the incinerator can be fitted with an electrostatic precipitators or a baghouse filters to remove the particulate matter in the flue gas. And this adds to the cost of the incineration process. Incineration reduces the volume of waste by 90 to 95% and by mass it reduces by 80 to 85% depending upon the combustion and the degree of recovery of materials. At this high temperature, it also possesses an advantage of killing the pathogens. The pathogens and harmful organisms are killed during incineration and hence used for treating biomedical or clinical waste. Incineration process also removes harmful toxins. In recent times, modern incinerators are also used to recover energy from the heat generated during this combustion process. Now, this energy can be used and converted into electricity since this advantage is associated with incinerators. They are categorized under systems where wealth can be recovered from waste. They are also called as waste to energy process. The heat that is generated from these incinerators are converted into electricity using the steam turbines. Now this image shows the incinerator, where if you can see, it's a double walled furnace where the waste is added and it is heated in the presence of oxygen to produce ash and other gaseous products. Now ash, again I told you, it is of two types. One is the bottom ash and the fly ash, and you also have other gaseous pollutants. Now what are the advantages of the incineration process? First, incineration requires less space in landfills. As incineration reduces almost 95% of waste volume, the ash that is left out as residue is taken to landfills for disposal. This reduces its space in the landfill. Second, incineration can be carried out near the point of waste collection. That means at the source of generation itself, you can install an incinerator and you can continue with the process, because they are considered as a compact units. So incinerators are compact units and hence can be set up at the source of waste generation or in transfer stations. They can be used as a decentralized systems. Incineration results in substantial reduction of weight by up to 75% and by volume 90%. Also, it makes the product sterile. Waste is reduced into biologically sterile ash product. At high temperatures of about 900 to 1100 degrees Celsius, the pathogens are killed and other harmful organisms present in the waste are killed, and hence they are sterilized. The residue, that is the ash which is left out after incineration, is hence termed as biologically stable. The incineration process does not produce methane gas unlike the landfills. As I mentioned earlier, waste, it is also termed as a waste to energy process. The waste incineration can be a source of low cost energy to produce steam for electric power generation, industrial process heating, or hot water for district heating, thereby conserving primary fuel resource. The bottom ash residue is considered as non-injurious and it can be used as a material recovery or as a secondary aggregates in construction. It is the best practical environmental option for many of the hazardous waste like the highly flammable waste, volatile, toxic and infectious waste. Now the disadvantages, first, the main disadvantage of the incineration process is the emissions from these incinerators. The incinerators, or during the process of incineration, a lot of gases are being generated. Now these gases such as the carbon dioxide, monoxide, oxides of sulfur, oxides of nitrogen are commonly emitted during the process of oxidation. Now they are serious air pollutants. Harmful emissions such as the furans and dioxins are also released when you burn the commingled municipal waste. The fly ash also contributes to particulate air pollution. These air pollutants, they endanger human health and also environment, and hence they require air pollution control devices. So when you inhale these particulate matter, it can just deposit in your respiratory system and it can lead to various breathing and respiratory problems. So that is a problem with this particulate matter, and the gases, as you all know, some of the health effects it causes. In addition to that, it also leads to a lot of environmental problems. The second disadvantage is that it involves a high investment, operation and maintenance cost. As incineration involves a very high energy, very high energy, that means around a temperature range of 900 to 1100 degrees Celsius, they are considered as energy intensive process, and hence they consume more amount of electricity for burning the waste. Thus, the cost of operation remains high. Moreover, the incinerators face problems of corrosion due to formation of sulfuric acid and hydrochloric acid during combustion. The emission pipes too get abraded due to the deposition of particulate matter, which becomes hard. These factors increase the cost of maintenance of these incinerators. A high capital investment cost is also involved for constructing these incinerators. An inorganic residue produced by the incineration process further needs the safe and proper disposal. The incineration plants are producers of a lot of heavy metals which are injurious even in minor amounts. Although modern incinerators comply with the existing legislation or laws, there is some public concern that the emitted levels may still have adverse effect on health. Incineration is designed on the basis of certain calorific value of waste. Removal of materials like the paper and plastics for recycling may reduce the overall calorific value and may affect the incinerator performance. Local communities have always opposed the presence of these incinerators in their locality due to the problems associated with the gaseous and the particulate emissions. They also require skilled operators, which will again add to the operation cost. Now, when this incineration process can be applied? Incineration can be applied only if the following criteria are being fulfilled. First, it can be used in places where the waste management is being practiced for a number of years. Second, at least 50,000 metric tons of waste should be available per year. Also, you should take care of the calorific value of waste, because the calorific value of waste is very important to achieve the efficient incineration. The calorific value should be at least between 7 megajoules per kg, and it should not be lower than 6 megajoules per kg. The community where the incinerators are installed should be willing to bear the cost tipping fees and the tax-based subsidies. The recruitment of skilled staff is also required if you have to go for an incinerator as an option. Now, let's look into the various systems which are available for the incineration process. An incinerator is designed in a way to maximize the combustion efficiency of waste and heat output. It should focus on minimizing emissions by balancing the oxygen and time, temperature and turbulence. The 3 T's, that is time, temperature and turbulence, should be maintained throughout the process. On the basis of the capacity, nature of waste to be combusted and the type of system, incinerators are classified into the following types. 1. The mass burn incinerator, modular incinerator, fluidized incinerator, starved air incinerator, refuse derived fuel and rotary kiln incinerators. Now, mass burn incineration. Incinerators done on a large scale is termed as mass incineration. It is a simple and a flexible method and is most commonly used for municipal solid waste. Around 2 to 3 or more incinerator units are used in mass burn incineration. The burning or combustion of waste is performed in a single chamber. It can combust around 1000 tons of waste per day. The process goes like: the pre-processed waste, that is the segregated waste, they are brought through trucks to the tipping floor. After the waste is tipped onto the floor, they are pushed into the pit through a bulldozer. The waste is then fed into the incineration chamber through a chute and a grate system. Since mass burn incineration combusts huge amount of waste, they are built in a way to recover energy. And in case of modern incinerators, it consists of a refractory lined combustion system with steam generator to recover energy in the form of heat or electricity. The steam generator is generally double-walled and lined with a refractory material. The water is circulated between these walls, which is converted to steam by the heat liberated during the incineration process. The modern mass burn incinerator is divided into 5 main areas. They consist of a waste feeding system, a furnace, heat recovery, emission control and energy recovery system. Waste feeding system. The waste feeding system consists of 3 units. One is a delivery system, one is a bunker system and a feeding system. The waste collection vehicles that enters a processing site are weighed at the entrance on arrival and departure to determine the charge for disposal and incinerator operation. The waste brought to the processing site are stored in bunkers till they are fed into the incinerators. Bunkers in general act like a temporary storage sites. Bunker can store waste in the range of 1000 to 3000 tons. They are divided into different sections for storing the waste of different calorific values. Long-term storage of waste leads to rotting and odor problem, and hazardous waste and bulky items are separated and then stored in bunkers. Feeder consists of a steel hopper through which the waste is fed into the incinerator, and through the grater by hydraulic ram the waste is fed. To avoid any air leakage into the furnace, the hoppers are half filled with waste and the hydraulic shutters are used to seal the hoppers at the furnace entrance to prevent the fire from burning back. Additionally, the feed chute can be a water-cooled or refractory lined to prevent fire. Furnace. Here the waste is fed into the incinerator through a controlled ram and it is fed in a way to combust around 50 tons of waste per hour. Sometimes multiple furnaces are used for combusting waste and this might act as a stand during repair and maintenance. The auxiliary burners are used to increase the temperature of the furnace, especially during the startup. Now, 3 stages of incineration occurs inside the furnace. One is drying and volatilization, second combustion of volatiles and soot, and third combustion of solid carbonaceous residue. Now, what happens in drying and devolatilization is, once the waste enters into the system, the moisture is removed as they are preheated. Then the organic matter undergoes thermal decomposition and results in the generation of a volatile organic matter, that is hydrogen, carbon monoxide, methane, ethane and other high molecular weight hydrocarbons. In addition to that, you also have combustible gases and other vapors which are being produced. Now, devolatilization occurs at temperature of 200 to 750 degrees Celsius and it begins at the end of the drying phase. And it also releases volatiles at a temperature of 425 to 550 degrees Celsius and depends on the nature and the physical state of waste. In the combustion of volatiles and soot, the volatiles released are burned in the combustion chamber located above the grate. The high temperature, complete mixing, excess air, long residence time are required for complete combustion of volatiles. The gases formed are subjected to 850 degrees Celsius for only 2 seconds to achieve complete combustion of volatiles. The temperature above 1200 degrees Celsius should be avoided to prevent the formation of slag by fusion of ash residue. The gases must be held in the combustion chamber for a minimum of 2 to 4 seconds to achieve complete combustion. Now, in a combustion of solid carbonaceous residue, once the volatile gases are being burnt, the residue consists only of carbon in the fixed form. The char is burnt in a grate for 30 to 60 minutes. The ash, that is the bottom ash, which is around 30% of solid waste, is discharged into water trough for cooling, which is then collected and disposed of in landfills. The fly ash, which is released out through the flue gas, is collected through cyclone separators, electrostatic precipitators and bag filters, and then they are disposed of. However, these stages are not clearly distinguished due to the factors involved in them. One, the moisture content, thermal degradation, volatile composition and ignition temperature are some of the factors. Now, this image shows how an energy can be recovered from an incinerator. If you see on the left side, you can see a truck dropping off the waste into the tipping floor. Now, from the tipping floor through a crane, the waste is being carried and then it is dropped into the incinerator. Now, slowly it is burnt and you can see the bottom ash which is collected through a conveyor belt and is taken on the other side through a truck to a landfill. And the flue gas which is generated is taken off to the pollution control devices like the acid gas removal system, that is a scrubber, and to remove mercury or dioxins, and then the particulate matter. And then the gas is just taken for pollution control tests and then released out into the air. Now, the steam or the heat which is generated is taken up and the heat that is generated is taken up and it heats up the water which is stored there and it forms steam. Now, steam is taken up to rotate the turbines and from which the electricity is generated. Now, next is the heat recovery. The heat generated during incineration process escapes as flue gas at temperature of approximately 1000 to 1200 degrees Celsius. The flue gas is cooled in boilers where the heat is used to boil the water and convert them to steam. The flue gas is of corrosive nature and hence it contains a high level of particulate matter. The emission control, the emissions such as flue gas, particulate matter and other acid gases such as the hydrogen chloride, hydrogen fluoride, oxides of sulfur and heavy metals are controlled using these air pollution control devices like the scrubbers, absorption units, cyclones, separators, bag filters and electrostatic precipitators. As mentioned earlier, for the energy recovery, the steam that is generated by the boilers, they rotate the turbine due to high pressure and temperature. Through various stages, the velocity of the turbine shaft increases and results in the generation of electricity. Around 0.3 to 0.7 megawatt per hour energy is produced from incinerators while combusting 1 ton of municipal solid waste. It depends on parameters like the calorific value, the plant size and the steam parameters. Now, the second type of incinerator is a modular incinerator, and this modular incinerator, they are small portable units. Their capacity varies between 5 to 120 tons of solid waste per day. They are more suitable for smaller communities, some commercial operation and industrial operations. And if you want, you can also add 2 or 3 units along with the existing units. A sequence of incinerators of capacity as low as 15 tons per day to a total capacity of 400 tons per day can be considered or constructed as a part of modular incinerators. Addition or detachment of units is possible, as I mentioned earlier. Modular incinerators are also prefabricated units and can be constructed within a short period of time. The cost of construction of these modulators are very less when you compare with the mass burn incinerators. A modular incinerator consists of a refractory lined furnace and a waste boiler system. There will be 2 combustion chambers which are used in a modular incinerator, where gas is generated in the first primary chamber is fed after burning to the secondary chamber to achieve complete combustion and minimize the emissions. The majority of modular units produce steam as a sole energy product and they are operated in both batch and continuous mode. The next type is a fluidized bed incinerators. Again, this is a small scale unit. The capacity varies from 50 to 150 tons of waste per day and it consists of a refractory lined vertical chamber with a bed of silica, sand, ceramic or limestone. Now, the air is blown from the bottom of the chamber to fluidize the bed material. The heat supplied to the bed and the increasing air velocities cause the bed to bubble. These beds operate under long residence time. and the solid particles are thereby exposed to the hot zone for a long period of time. The turbulence generated within the chamber causes the solid material to flow above. Now, the cyclone separator is fixed to collect and recirculate the material back to the bed. The advantage of doing so is better combustion with minimized air emissions due to high burnout. To achieve better combustion, the bed material also should be preheated. Also, you can shred the waste and add, which will also increase the combustion efficiency. The dispersion of incoming waste and sufficient residence time are major reasons for complete combustion in a fluidized bed incinerators. Now, there are two types of fluidized bed technologies. One, the bubbling bed, and the other one is circulating or turbulent bed. The airflow pattern, bed material, and the type of waste differentiate the bubbling bed and the circulating bed incinerators. Now, fluidized bed incinerators are more compatible with high recovery recycling systems. Now, some of the advantage and disadvantage of the fluidized bed system include: the advantages are they are relatively low in capital and maintenance costs because of their simple design aspect. They have a very high thermal efficiency of around 90%. They are very flexible, they are consistent, and they have a very high energy conversion efficiency. Also, they produce less ash, resulting in lower emissions. They are suitable for handling both solid as well as liquid waste, both either separately or in combination. They also reduce the toxic substances and other dangerous substances, and they have a multi-fuel input. The disadvantages are it is not so common, nor it is a completely tested technology. It requires pretreatment, and stringent requirement for size, calorific value, and ash content is required. Relatively strict demand to size and composition of waste is essential. The next type is the refuse derived fuel. The refuse derived fuel, or termed as RDF, are referred to solid waste that is mechanically processed so that it can be used as a fuel. Now, RDF are easily stored and transported for use anywhere in the world. It is prepared by two steps. One is the RDF production and RDF incineration. The waste material is segregated, shredded, and then pelletized. How is it done? Is the waste is dropped into the tipping floor, and through the conveyor belt it is carried to a segregation or a sorting site. The waste is carried through conveyor belt on top of which a strong magnet is passed to separate the ferrous metals. After the basic screening, the waste is then made into small pellets by pelletizing units. Now, RDF is incinerated in combustors. Two types of RDF systems are there. One is simplified and the other one is shred and burn systems. In a simplified system, the non-combustibles are removed, about 85% of ferrous metals, and non-combustibles such as dirt, sand, non-ferrous metals are removed, and they are segregated, and the segregated waste is then shredded to a size of 10 to 15 centimeter, and then they are fed into incinerators. In a shred and burn type, they do not focus on removal of combustibles. The waste that is dropped onto the tipping floor is shredded and then directly fed into the incinerator without any segregation. Now, this type of RDF production is considered to be easy and simplest, but because it requires minimum processing. But the ash that comes out of the incinerator can be subjected to a magnet for the removal of non-ferrous metals. Now, depending on the combustibles, the ash content also will vary. Higher the combustibles, lower will be the ash content. High ash content will always lead to a low quality fuel. So, when pre-processing of waste is carried out before incineration, it will add to the operating and the maintenance cost. It will also reduce the reliability of the RDF production process. Generally, RDF technology is more costly than all other incineration process. The next type of incinerator is starved air incinerators. Again, it is a small scale system with two combustion chambers, pyrolytic and combustion chamber. They are widely used for clinical waste, that is the biomedical waste. These systems are smaller than modular incinerators and they have a capacity ranging from 5 to 100 tons per day. Similar to modular incinerators, the additional units can be added according to the requirement. In a pyrolytic chamber, the waste is chemically decomposed by the action of heat in the inert atmosphere. During heat, a gas is generated which is when ignited becomes self-supporting in air. Due to insufficient oxygen, high proportion of incomplete products are formed. The carbon and hydrogen that is formed is sent to the second combustion chamber where they are subjected to 200% excess air. Now this will increase the temperature of the chamber and will end up in combusting the waste. And hydrogen and carbon monoxide will be converted into carbon dioxide. The dioxins and the PCBs are also broken down in the second chamber, and during this process NOx is not formed. In the second chamber, turbulence and mixing occurs due to gas that enters from the first chamber. The advantages of this process include it is a controlled combustion process, it releases less amount of volatile organic compounds and carbon monoxide, and also low level of particulate matter is released in the flue gas. Low combustion temperature in the primary chamber aids in pollution control by minimizing the vaporization of metallic components of the waste. The construction time is very less, I mean it can be constructed very fast, and they have a relatively low construction cost, so they are also flexible systems. Now looking into the disadvantages, they are of limited size, they show a lower thermal efficiency, they require a very high maintenance cost and a shorter equipment life. When you are using the incineration process with an objective of generating energy from the incineration process, it is essential for us to know the energy content of waste. Now this section will help you in calculating the energy content of each waste. Now the energy content of waste can be calculated using the values of ultimate analysis of waste. Ultimate analysis, which we have already studied in the previous module, which involves the analysis of the carbon, hydrogen, sulfur, oxygen percentage of waste. Now the energy content of waste can be expressed as either kilojoules per kg or BTU per LB. Now energy content can be calculated using DeLong's formula, which is given below, which denotes like 145.4 carbon plus 620 into H minus 1/8 of oxygen plus 41 S, where S denotes sulfur, C denotes carbon, H denotes hydrogen and O denotes oxygen. And all these are taken as percentage by dry weight basis. Now you can convert the value which you get is in BTU per LB, and if you multiply the value with 2.326, you can get the energy content in terms of kilojoules per kg. Now this table shows you the ultimate analysis of the combustible waste. The types of waste are listed in the left column, where food waste, paper, cardboard, plastic, textile, rubber and so on. And on the right side you can find the percentage of carbon, hydrogen, oxygen, nitrogen, sulfur and ash for each particular waste. An example is provided here for calculating the energy content of food waste, which is given below. Now as based on the ultimate analysis, you can see the food waste possess an energy content of around 8049.6 BTU per LB. To summarize, at the end of this module, we have studied about the combustion, what is a combustion process, how the combustion process occurs in the presence of oxygen, and how high temperature and oxygen can break down or thermally destruct the waste into the gaseous products and a solid residue called as ash. Now, incineration is a type of combustion process where the waste is subjected to a temperature of around 900 to 1200 degrees Celsius in the presence of oxygen. It results in the release of gaseous products and a solid residue called as the bottom ash. Some amount of solid residue are also released along with the flue gas called the fly ash, and to avoid their emittance into the outer or external environment, you can connect the air pollution control devices which will minimize your particulate as well as gaseous emissions. Now then, we also looked into the various advantages and disadvantages of the incineration process. We discussed about the various incineration technologies like the starved air incinerators. We discussed about the mass burn modular incinerators. We also discussed about the refuse derived fuel incinerators, and also the advantages and disadvantages of each of these incinerators. We also studied about the energy content, how to calculate the energy content of a waste from the ultimate analysis of waste. We also listed out the various conditions where the incineration technologies can be used. Thank you.